Hello and welcome to session 2 of 6 for Riverbed's RCSA exam preparation. My name is Bob Ashmore. I'm a channel sales engineer here at Riverbed. Let's get right into it. Let's talk about how auto discovery works. Steelhead appliances do not need to be configured to find other steelhead appliances. They automatically find each other. They find each other during the initial three-way handshake where a client is trying to talk to a server. Let's go through how that works. The SYN comes from the client and is destined for the server. As that SYN packet goes through or traverses through a steelhead appliance at the client side, that client side steelhead intercepts that packet and marks that packet. This SYN, as it's approaching the steelhead appliance, we're going to refer to as a naked SYN, meaning it is not been marked. It's a naked SYN that hasn't been marked by a steelhead appliance. Once that SYN arrives at the steelhead appliance, it is then marked. What we use is the TCP option field to identify the appliance. Now we should know that the SYN marking is using 76 decibel or 4C in hex. Make sure you know that. It's definitely on the exam. So we place this marking in the TCP option field and pass the SYN across the network on its way to the server. The steelhead appliance on the other side of the network, closest to the server, sees this marking within the SYN packet and knows that there's another steelhead appliance that's trying to optimize this connection. So the steelhead appliance next to the server responds with a SYNAC plus, meaning that it knows that the other steelhead wants to optimize with it, and the SYN packet is passed to the server. The server then responds with a SYNAC, and finally the steelhead appliance at the client sends a SYNAC to the client. Now we've established the 3 separate connections and we've established optimization without having to do anything other than ride along on the back of a SYN packet. Next, let's talk about enhanced auto discovery, which became available in version 4, which was, 2 or 3 years ago. Basically, the way enhanced auto discovery works is that the steelhead appliances are able to automatically determine whether there are multiple steelhead appliances in a line, and then optimization automatically occurs between the steelhead appliance that's closest to the client and the steelhead appliance that is closest to the server. What we don't want to have happen is 2 appliances that happen to be right next to each other. We don't want to create an optimization between those 2. We want the optimization to occur over the long haul. Notice that auto discovery is turned off by default in this version of code. So if you're asked about that on the exam, the answer is that auto discovery is turned off by default. Next, let's talk about in-path rules. In-path rules determine how traffic should be optimized. So the steelhead administrator creates these in-path rules in order to tell the steelhead what traffic should be optimized and with which options, and which traffic should not be optimized. There are 3 default in-path rules, which we'll talk about in a minute, but we often create additional in-path rules to specify how we want things optimized. And it's critical that we memorize these 5 different types of in-path rules. The first is a pass-through rule. Pass-through rules mean exactly what they sound like. Pass the traffic through without trying to optimize it. Don't even send a SYN, a marked SYN, across to try to optimize it. Next, there are auto discovery rules. This is what we just discussed in the previous 2 slides. This is standard behavior for a steelhead appliance. A client sends a SYN, it's trying to establish a connection with a server, and we will allow the steelheads to determine automatically which other steelhead appliance to optimize with. Next, there are fixed target rules. Fixed target rules often are used in environments where we're doing server-side out of path or where we have traffic which is being passed through environments where our probes, our marked SYN packets, are stripped. So some of those type of environments include satellite environments where if they're doing header compression, they may decide that the option field is unnecessary and remove our TCP option or our probe. So what we do there is we establish a fixed target rule. This means traffic going from this client subnet to this server subnet will optimize with this specific steelhead appliance, and we specify the IP address of that appliance. Okay? That's a fixed target rule. That's where you're manually defining the destination steelhead appliance. We can also do a discard and deny, which is similar to the behavior of a firewall. So discard means silently drop the packets, and deny means drop the packet while also sending a reset back to the sending node. These rules are processed in a top-down order until there's a match. So if you've got a list of rules, the first rule that matches, very similar to a firewall, is the rule that is executed. And only one rule is applied at a time. As soon as we reach a rule that matches, then that's the rule we execute, and we don't execute any other rules for that connection. Also, in-path rules are only inspected on traffic coming onto the LAN side of the steelhead. So if a SYN packet shows up on the LAN side of the steelhead, then we're going to inspect the in-path rules to determine what to do with it. If a SYN packet shows up on the WAN side of the steelhead, a naked SYN, we are not going to try to optimize it. Next, let's look at how we configure these in-path rules. Notice that the default in-path rules are listed there: secure, interactive, and RBT proto. We'll talk about those. And then there's a default auto-discovery in-path rule, which basically means try to optimize all other TCP traffic. You can define the source and destination subnets, as well as you'll notice that you can define the destination port. One thing you'll notice is not there is the source port. So when you get to the question on the exam, which asks you which of the following three components of a conversation header are supported for an in-path rule, and we ask you whether it's source and destination IP address, source and destination port, the one that is not configurable is source port, of course. Also notice that we can define optimization policy types. So there are three different types that we can define in the in-path rule. One is normal, which means perform LZ and SDR. You're going to use this 99% of the time. We can also write rules that specify to use only SDR only or compression only. SDR only means perform just SDR, which means look for matching chunks in the scalable data referencing data store, but do not try to compress the data. An environment where we might want to try to do this is if it's pre-compressed data. That data is pre-compressed the same way every time. However, the data is still redundant. So there's no need to try to recompress this data when we know that we won't get any additional compression. But we will find redundancies. Okay? The next example is compression only. We perform LZ compression only. This is when we know that the data is compressible, but it's always brand new. We never see redundancy, but it is compressible. So this allows you to alleviate some of the CPU pressure on the steelhead by defining traffic that does not need to be fully, there's no need to utilize all of the technology because there won't be any additional gain. There also is none. None means don't perform any LZ or SDR optimization. A lot of times I ask people, what's the difference between performing no optimization like this or creating a pass-through rule. The difference is a pass-through rule does nothing, passes the data through without trying any type of optimization. Whereas if we choose none here, we will still do TCP optimizations as well as layer 7 optimizations. Okay? Next, let's look at the Riverbed ports that are frequently asked on the exam. So some of the ports that we want to memorize are, first of all, the data store synchronization port, which is 7744. And I always try to remember that because it's 77 and 44. In fact, if we move on to the next slide, you can see the little tip I came up with for how to memorize these different ports. So the main in-path optimization port is 7800, and that starts with an I. Then 7810 is the out-of-path port, which is used for server-side out-of-path optimization. Then there's the failover port used in serial clusters, the MAPI port, the other MAPI port, which is the NSPI port, as well as connection forwarding, and the interceptor appliance port and Steelhead Mobile. So the way I memorize these is I write down 7800 and then I put 10, 20, 30, 40, 50, 60, 70. And then I write, I own far more new cars in Sacramento. Now, if you don't live anywhere near Sacramento, you may want to come up with another city. Or maybe you want to think of, I own far more cars in Mobile, Alabama, or something like that, so that you remember that the last 7870 is mobile. Then we can write this down on our 8.5 by 11, and when we get into the room, we can write it down onto the dry erase board and quickly and easily be able to glance at our board when a question comes up about these port numbers. A couple of port numbers that we need to know which are that don't fit this trick include 7801, which is our TCP, our NATing port, as well as the data store sync port, which is 7744. So 77 is very close to 7800, and 77 and 44 are somewhat synced, is the way I think of it. So that should help. Next, let's look at the default pass-through rule ports. So the interactive ports are listed here. They include Citrix. Now with newer versions of our code, with newer versions of Rios, we provide optimizations for Citrix. So in that case, we would remove these from the interactive list. Also, the secure ports are listed there. For some reason, there's a star next to port 49 for TACACS. You might want to make sure that you memorize that port 49 is the port that TACACS conversations go over. Next, we need to talk about peering rules. Peering rules are the corollary to in-path rules. So recall that in-path rules act on naked SYNs that show up on the LAN port of the Steelhead appliance. Now, peering rules act on probes or marked SYNs that show up at a Steelhead appliance. And it could be either the LAN or the WAN port. Okay? So if we see traffic arriving that is marked, meaning that there is another Steelhead appliance on the network that wants to optimize, then we will investigate the peering rules to determine what we should do. We need to memorize these three types and don't get them confused with the in-path rules. The first type is auto. Auto means determine what is the best response. Should I optimize with this or not, based on the rules of automatic peering. Next, should we accept, which means blindly accept the request from the client. That means that we would be overriding the automatic peering rules and we would accept traffic coming from this source subnet. Or a pass-through peering rule, which means do not accept any optimization traffic, any attempts at optimization. So auto, accept, and pass are the three that we need to memorize. Now let's move on to Steelhead system states. The first state is healthy. Healthy means that we are having no problems with the Steelhead appliance. Next, you'll notice, is admission control. Admission control happens when the number of Steelhead connections that the appliance is optimized for has been exceeded. So if I own a steelhead appliance, which is licensed for 1,000 connections, then once I reach 1,001 connections, then the device is going to go into admission control. Now what does that mean? What happens other than the status changes to admission control? Well, when we exceed the number of connections that the device is licensed for, then those additional connections go into pass-through mode. So any connections in excess of the number of licensed connections will be in pass-through. We can also be in degraded mode, which means the appliance is optimizing, but not necessarily optimally, or in critical mode, where the appliance may or may not be optimizing, but this is a critical situation that needs to be addressed. Maybe one of the drives in the RAID has failed, and we need to replace that, as an example. Next, let's talk about data store synchronization. Data store synchronization refers to an environment where you have two steelhead appliances that are next to each other, for example, in a high availability configuration, where you've got one steelhead appliance going out one WAN link and another steelhead appliance going out the other WAN link. And it's possible that connections could come in or out on either side. We don't want traffic that passes through one connection to come back on the other side as a cold transfer. Meaning we want the data stores on both steelheads in the same location, mind you, to be the same. The data store should be synchronized between those two devices. So every chunk of data that's in the data store on one box should be also in the data store on the other box. That way, if one of the WAN links fails and the other WAN link takes over, then that appliance will already have a warm data store. So remember that data store synchronization occurs over port 7744. That failover is not required for data store synchronization, but the requirements include that both steelheads be running the same major version of RIOS. They need to be the same identical model of steelhead hardware appliance, and we need LAN-like connection between these two devices. Again, these are for two devices in the same physical location, and the data store synchronization needs to be less than 10 milliseconds between these two devices. Riverbed hardware. Let's investigate what the different hardware capabilities are and what's asked about that on the exam. So here's a look at the different appliances. Notice that we have devices that range in size from the smallest device, which is the 250L, and go all the way up to the 6050. Obviously, today there are larger appliances, but for purposes of this exam, the largest appliance is the 6050. We'll be talking about interceptors and the CMCs, as well as Steelhead Mobile and the Steelhead Mobile controller in other modules in this exam preparation video. The hardware consists of devices which are both sub 1U, 1U devices, and 3U devices. Notice that the sub 1U devices are the 250-550, and then the 1050-2050 are the 1U devices. The 250 and the 550 have a single LAN and WAN port, so one in-path interface made up of two ports, the LAN and the WAN port, as well as a primary port and an auxiliary port for management. Notice on the 1U devices that the 1U devices have redundant power, which is not available on the 250 and the 550. Make sure you know that for the exam. Basically, if your customer needs redundant power, then they need to move to a 1U device. Also notice that there is the capability for additional WAN ports on the Steelhead appliance. So the Steelhead appliance itself in the 1U is configured with two in-path interfaces. So that's two LAN and WAN ports to support two WAN links. There is also an expansion slot, which is PCIe, which allows you to add additional bypass cards to support additional WAN links. And again, notice that that's PCIe and not PCIX. Now let's look at the 3U models, the 5050 and the 6050. The 6050 and the 5050 come with redundant power. They also have a pair of in-path interfaces, so you've got two LAN and two WAN interfaces to support four WAN links. To support 4 ports over 2 WAN links. And of course, the expansion slots are available in the 3U models as well, and those are PCIe, not PCIX. Let's talk about some of the NIC and port details. As was mentioned multiple times, the NICs are PCIe. The primary and the auxiliary port cannot be on the same subnet. However, the primary port and in-path interfaces can be on the same subnet. We use the primary port for doing server-side out-of-path deployments, and we use the WAN port for out-of-path deployments, which we'll talk about in more detail coming up. That include WCCP, PBR, and Interceptor. In-path interfaces are named based on the port, then the slot, and the pair that they're in. So for example, you will have LAN 00 and WAN 00 are a corresponding pair of ports that make up an in-path interface. And the in-path interface acts as a bridge which logically sits between those LAN and WAN ports. Notice that the maximum number of in-path interfaces is in red. There are a number of questions on the exam about this. So the desktop boxes, the 250 and the 550, support one in-path interface. That's a LAN and a WAN port. The 1U appliances support a maximum of 4 in-path interfaces, so that's 4 WAN connections. And the 3U appliances support 10 in-path interfaces, so 10 WAN links simultaneously. All right, let's move on to the questions for Section 2. Section 2 says, question 1 says, admission control alarms are triggered when A, bandwidth utilization exceeds the appliance capability, or B, the number of optimized session exceeds the appliance capability, or C, the data store is full, or D, an unknown problem has occurred. The correct answer, of course, is B. Admission control occurs when we exceed the license capacity of the steelhead as far as connections go. Next, let's talk about ports. What port needs to be connected in a logical in-path configuration? We mentioned this briefly previously, and the correct answer is the WAN port. Next question, which appliance models provides multiple in-path interfaces without adding additional network cards? And if this were a real question on the exam, it would tell you to select 3. Remember that the 250 and the 550 do not support additional interface cards, and also remember those are PCIe and not PCIX. So the 1U and the 3U models support additional bypass cards. How many in-path rules will a single LAN-initiated connection match on a steelhead? So every SYN that shows up on the LAN port of a steelhead appliance, how many in-path rules are executed? Remember that is 1. Once one in-path rule matches, then that's the one that's executed. Next question. What are not default port labels on the steelhead appliance? And we say to select 2. So remember that we're talking about port labels and not in-path rules or peering rules. So those are secure, interactive, and RBT proto. So the other 2 are not. Next question. When performing a logical in-path deployment, which interface needs to be physically cabled for optimization to occur? Logical in-path. Remember, we use WAN 00 for that. And that is the end of section 2 of 6. Thank you, and we'll see you in other sections.